Good evening, ladies and gentlemen, or morning in your case. Um, we are going to go through Lewis Structure's practice set number 3. So, um, these are most review, but if you have any questions while I'm going through these or don't understand something, please feel free to message me either an email or Hangouts. So, our first one is CH4. For carbon, we have 4 electrons. For hydrogen, we have 1 electron times 4. So a total of 8 electrons or 4 pair. Okay. If carbon is present, carbon goes in the center. Because there are 4 hydrogens, we put 1 coming off each side. Check to make sure carbon is happy. It has 4 bonds, so it's happy. Each hydrogen only has 1 bond to it, and so that makes it happy, and total we used 4 pairs. So that is done. Second one is NH3. So nitrogen has 5 plus our 3 from hydrogen. So that's 8 electrons or 4 pairs. Odd man in the middle, so nitrogen in the middle. It gets 1 set of unshared and then 3 bonds around it. There are 3 hydrogens. So I'm going to put 1 hydrogen off of each bond. Check to make sure nitrogen is happy. 1 set, 2, 3, 4. Each hydrogen has only 1 bond coming off of it, so it's happy. Total, we use 4 pairs. 1, 2, 3, 4. So that looks great. Our next one is H2O. Hydrogen brings 1 electron to the table, but there are 2 of them. So 2 plus our oxygen, which has 6 valence electrons. So again, a total of 8 electrons or 4 pairs. Odd man in the center, so we have oxygen in the center. Oxygen has 2 unshared pairs of electrons on it. Coming off, it will also have 2 bonds. Conveniently, we have 2 hydrogens for those bonds. Make sure everything's happy. Our oxygen has 8 electrons, 2 pairs, and then 2 unshared pairs. Each hydrogen has 1 bond coming off of it, so they're all happy. Total, we use 4 pairs. 1, 2, 3, 4. Next, we have SiF4. Si has 4 electrons, plus we have 4 fluorines, so 4 times 7. Total, that is 28 and 4, so 32 electrons, or 16 pairs. Okay. I'm going to start with my silicone in the center because it is in the same row as carbon, so it also needs 4 bonds coming off of them. There are 4 fluorines, so I'm going to put 1 fluorine off of each bond. Each fluorine, when I draw fluorine by itself, has has 6 electrons. So I still need to draw all of those 6 electrons on each fluorine. For now, we need to check to make sure everything's happy. So each fluorine is good with 8 electrons, 6 electrons, and then 1 set. And then their center silicone has 4 bonds to it, so it's happy as well. Next, we have NCl3. So N has 5 valence electrons plus chlorine has 7, but there are 3 of them, so that's 26 electrons or 13 pairs. Okay. Our odd man goes in the center, so N goes in the center, and because it has 5 valence electrons, it has 1 unshared pair and 3 bonds. We have 3 Cls, so we place one of those in each bond. Chlorine is drawn much like fluorine with 6 valence electrons on its own. And then 1 pair. Check to make sure everything is happy. Our N has 4, and each chlorine has 4. Moving on to multiple bonds. Some people just did these and did not notice that it says multiple bonds there. So these are going to have either double or triple bonds. Our first one has H2CO. Therefore, we have 2 for hydrogen, plus our 4 for carbon, plus 6 for oxygen. A total of 12 electrons or 6 pairs. Okay. Carbon goes in the center. It has 4 electrons. So I have H, and then my O over here. Oxygen has 2 unshared pairs, and then it needs 2 bonds. One is going to be here between the C and the O, and then there's going to be another one between the C and the O. Check to make sure everything's happy and that we've used the correct number of electrons. Each hydrogen is happy. Carbon has 4 bonds, so it is happy. Oxygen has 2 bonds and 2 sets of unshared electrons, so it's happy. Did we use 6 pairs? 1, 2, 3, 4, 5, 6. We are completed with H2CO. Next, we have HCN. Our H has 1, plus carbon has 4, and nitrogen has 5. So we have 10 electrons or 5 pairs. Carbon goes in the center again. I have 1 H, so I'm going to put my H there. Now I know when I draw nitrogen, it's going to have a single pair of electrons and need 3 bonds. Carbon also needs 3 bonds, so we put 3 bonds between them, a triple bond. Make sure everything is happy. Hydrogen has 1, carbon has 4, nitrogen has 4. We only use 5 pairs. 1, 2, 3, 4, 5. Next we have C and O. Carbon has 4 electrons, oxygen has 6. So we have 10 electrons or 5 pairs. I have C and O. I know that the only unshared electrons, there should be 2 pairs. I'm going to put 1 on C and 1 on O. And to make them both happy, they each need 3 that they're sharing. So carbon has 4 total, oxygen has 4 total. We used 5 total. 1, 2, 3, 4, 5. Next we have CO2. Carbon has 4 plus 2 times 6. So that's 16 or 8 pairs. Carbon goes in the center with 1 oxygen on each side. Each oxygen gets 2 unshared pairs. But carbon is not happy yet, and neither is oxygen. So they each need 1 more pair. So we add a double bond. Check to make sure oxygen's happy. It has 4. Carbon has 4. This oxygen has 4. Check to make sure we only used 8 pairs. 1, 2, 3, 4, 5, 6, 7, 8. Continuing on with multiple central atoms. I know these gave several people a lot of issues that they didn't understand what was going on. So, first we have multiple central atoms. So, let's figure out the numbers. Carbon has 2 atoms times 4 is 8, plus our 6 from hydrogen is 14, or 7 pairs. So I have 2 carbons. I'm going to go ahead and put those in the center attached to each other. Then I have 6 hydrogens. Carbon needs 4 bonds, so it has 1. Split them evenly between the 2 hydrogens, or between the 2 carbons. Each H is happy, each carbon is happy, and we used 7 pairs. Okay. Our next one is C3H8. So to figure out the numbers, 3 times 4 is 12, plus 8, 20 electrons that we're working with, 10 pairs. Carbon, carbon, carbon. I have 8 hydrogens. So this carbon needs 3 because it only has 1 bond. So 1, 2, 3. This carbon has 2 bonds, so it needs 2 more. This carbon has 1 bond, so it needs 3 more. We used all of our hydrogens. We used all of our carbons. Do we only have 10 pairs? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. And everything is happy. Our next example is C2H5OH. So again, I'm starting with my math. I have 8 plus 5 plus 6 plus 1. So 12 and 8 is 20 electrons, or 10 pairs. Okay. Start with our 2 C's in the middle, carbon with carbon. Then I have 5 H's. So this carbon needs 3. So that carbon is happy. I have 1, 2, 3 hydrogens, so I need 2 more. This carbon will take those. I have an O and an H left. If I put an H here, I am done. So I cannot add any more. However, if I put an O here, an O has 2 unshared pairs and then a hydrogen. Everything is happy. Every H only has 1 line. Every carbon has 4. And then oxygen has 2 unshared pairs and 2 bonds. So everything's happy. Did we use 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. We have C2H4. So that means we have 8 plus 4, 12 electrons, or 6 pairs. Start with my 2 carbons in the center. Place my 4 hydrogens. 1, 2, 3, 4. Carbon is not happy yet because it does not have 4 bonds. And we have used 1, 2, 3, 4, 5 bonds. So we only have 1 more. I can make these both happy by putting another bond there. Then I have a total of 6, and each carbon has 4 bonds. Last example, C2F2. So I have 8 for carbon plus my 14 for fluorine. 8 and 14 is 22, or 11 pairs. Start with my carbon, and then I'm going to add my 2 fluorines, 1 coming off each carbon. Each fluorine has 6 valence electrons that are not bonded to anything. So I'm going to add those. This fluorine's happy, this fluorine's happy. Carbon is not happy. It only has 2, and this one only has 2. Now we used 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 2 more, and I need 2 more bonds to each one, so this is going to become a triple bond. Every carbon has 4, every fluorine has 4, everything is happy. And we used 11 pairs. If you guys have questions on anything, please let me know. Feel free to message. Also, we are going to start having Google Meets on Wednesday at 1 o'clock.